Okay, so I wanted to talk about resonance structures today. I'm going to go ahead and apologize in advance for my lack of ability to draw hexagons. But aside from that, you should be able to see with what I'm doing, like how the movement of electrons affects the structure of an atom. Okay, so first we're going to start off with an example. We'll do this. Oops. Alright, now I think I'm probably going to get a different program to draw these things in the future, but for now we're going to deal with this because this kind of looks like a hexagon, I guess. Alright, now with resonance structures, you don't have, like, it's going to be a combination of all of the resonance structures you make. That's what the actual atom looks like, or the actual molecule looks like. So, to draw resonance structures, we use arrows to show the movement of electrons. Now, in a lot of cases, people like to draw them with hydrogens in there, and that helps. I know that helps. I know that helps some people to kind of see what they're supposed to be drawing. But for me, it seems a bit easier not to worry about that. But I'll go ahead and draw them in there so that you can see. Whoops. That one's a positive charge. Okay, sorry. Goodness. Sorry, guys. So you should draw those in there first. Alright, now, that's what it looks like without with the hydrogens in there. Alright, so we're going to draw the movement of electrons by arrows. Now, to do this, we're going to have to try to figure out where is an open spot. Well, obviously, electrons have a negative charge, so that already tells you that they're probably going to move towards this positive charge. Alright, and so we're going to go ahead and draw that. And a double arrow represents one electron, or two electron, a pair. And then a half arrow, if you ever see that, represents one. Okay, so, and you denote it by a double-headed arrow going both directions. Okay, now we've moved that to that side, and that stays there. Okay, now when we move our electrons over, that means that this carbon's going to have sufficient bonds, and this carbon will have sufficient bonds, so we're going to move the plus charge here, and we can draw another resonance structure. Right here. Oh my goodness. Sorry guys, I'm terrible at these. Alright, and now we have our movement of electrons to this position, which leaves this open. Alright, and we can't draw anymore. This is going to be the the only amount of electrons that we can draw, because if we try to move, we can't skip spots in resonance structures. You can only go to the next bond. So our molecule is going to look like a combination of each of these. Each of these is equally likely to be the state that it's in at any time. So basically, if you want to think about it this way, they're kind of sharing like electrons over this portion of the atom right here. They're kind of like sharing those electrons throughout this region because of the resonance structures. And you'll find that resonance structures add to its stability, and other videos will get over that. Thanks guys.